Okay, well, I think we're in a good place to begin. So good morning and welcome to this permit streamlining training for electric vehicle charging station installations. Shayna, we're going to be recording this morning. Are you able to start that recording?
Yes,
great.
You're all set.
So wonderful, thank you. This training will highlight important actions that you can take to position your community for electric vehicle infrastructure investments. I'm Jessica Wilcox. I am the Grants Manager in the Air Resources Division at the New Hampshire Department of Environmental Services, or DES. I'm also coordinator for the Granite State Clean Cities Coalition, or GSCCC, which is a program hosted by DES. So a couple of webinar logistics. Everybody is muted today. We are going to be recording this webinar and hopefully sharing that with everybody and others. We do invite you to ask questions using the Q&A feature. Please make sure your questions are clear and concise. You can enter them throughout the webinar. And please try to identify the name of the speaker that your question is directed to. If you have any technical issues, please use the chat feature. And these are at the bottom, located in the control panel, which is likely at the bottom of your screen. So I'd like to introduce the other presenters that we have with us today. James Penfold is the co-founder and CEO of EV LaunchPad, a New Hampshire manufacturer of EV charging system infrastructure. They are a proponent of the industry standard, more agnostic software that allows property owners to select the best features and cost for their use today while remaining flexible for the future. James is also an active member of Drive Electric New Hampshire, the state's EV advocacy group, and he organizes the annual Portsmouth Drive Electric Week event. Thank you for being with us today, James. And Sean Tolley, he's the project lead for Eversource EV Charging Stations program. He draws on more than a decade of engineering and project management experience to deploy EV charging infrastructure at municipal, commercial, and industrial sites throughout Massachusetts. Now, prior to working with the EV charging station program, he led the implementation of energy efficiency improvements at the U.S. Coast Guard Academy as part of the largest utility energy services contract ever awarded through the Department of Homeland Security. Now, I'd like to turn it over to James to give us a little bit of background, James, about you and your work.
Thank you very much, Jessica. Appreciate you having me here today. So a little bit of background, EV LaunchPad is based in Portsmouth, New Hampshire. We have been installing charging stations all over New England for the past 3 years, and also design and manufacture our own stations right here in New Hampshire. Charge Depot is the world's first turnkey rapid deployment charging system. And Powerbase, our other product, is a universal mounting platform with integrated cable retractors and a proprietary anchoring system that significantly minimizes installation time. Since it is relatively early days of EV adoption in New Hampshire, we have mostly experienced smaller projects of 1 to 2 double port charging stations. These are typically installed in existing parking lots and require tearing up asphalt and sidewalks. I just thought it might help as a frame of reference to understand that these smaller installations normally run at about $10,000 to $15,000 to install a double port, plus the cost of the charging hardware at about $5,000 to $10,000, for a total project cost of between $15,000 to $25,000. As you may imagine, this is a substantial investment, and it is a challenge to get property owners to commit to this cost without any grant money, for example, as they might have in Massachusetts, and with a totally uncertain return on investment, especially while everyone's budgets are being seriously stretched during the pandemic. So that said, anything that all stakeholders can cumulatively do to bring down the cost in time and money will help incentivize the deployment of charging stations, with the benefit of promoting clean energy EV usage in our communities, and make a statement to visitors that your municipality welcomes EV drivers. I especially welcome this presentation, as we have found that the permitting and inspection process can literally make or break whether a project stays on track, and significantly impacts the overall cost. A streamlined process will make projects more predictable and bring in more contractors, resulting in a competitive bidding that will drive down costs and accelerate the deployment of charging infrastructure. I appreciate Jessica inviting me here today and look forward to engaging with you all throughout the presentation. Thank you.
Great, thank you, James. So now we'd like to know who we have with us today. I'm going to launch a poll and ask you to please select your affiliation by responding to the Zoom poll that is currently on your screen. I'm going to give everybody a few seconds here to respond. A couple more people available to vote. I think we got almost everybody here. All right, I'm going to close this poll. And looks like the majority of people joining us today are other. So would love to have you reach out to me, let me know who you are and what caused you to tune in today. Regional Planning Commission staff, fabulous, welcome. Municipal office and technical staff, thank you so much for joining. And to that code enforcement official out there, thank you so much for tuning in. We look forward to providing some great information for everybody. All right, close that. So now for the agenda, I'm going to begin with an introduction to our Granite State Clean Cities Coalition, provide some overviews of electric vehicles and charging stations, considerations for you to strategically position your community as an electric vehicle hotspot, and provide some best practices considerations for streamlining the permitting process for charging stations. Now, before I begin, I want to clarify a couple of acronyms I'll be using throughout the presentation. I may alternate between using the term electric vehicles and the acronym EVs, and between EV charging stations, also known as electric vehicle supply equipment, or EVSE. So let's begin. Granite State Clean Cities Coalition, or GSCCC as I refer to it, is part of a nationwide network of nearly 100 Clean Cities coalitions supported by the U.S. Department of Energy, or DOE. We work with vehicle fleets, businesses, and municipalities to reduce petroleum use in transportation, and we do this through the advancement of alternative fuels, electric vehicles, and other technologies, and through fuel efficiency strategies like idle reduction. Now, alternative fuel vehicles are vehicles fueled by something other than gasoline or diesel. Think natural gas, propane, biodiesel, including electric vehicles. We are fuel agnostic and technology neutral, and on-the-ground Clean Cities coordinators like me work with our stakeholders and partners as educators and problem solvers. In New Hampshire, our coalition is made up of over 140 stakeholders consisting of public and private fleets, such as state, municipal, utilities, and fuel and beverage supply companies, businesses such as fuel providers and vehicle manufacturers, municipalities such as schools and universities, regional planning commissions and energy and sustainability committees. And all of these stakeholders, or partners as I prefer to call them, because there are no fees or member dues that are required to join our coalition, all of us are working in support of our mission to improve air quality and foster economic development in New Hampshire's transportation sector. And we do this through collaborative partnerships and projects that promote petroleum reduction strategies. Now, since inception of the Clean Cities program in 1993, Clean Cities Coalition's projects have achieved a cumulative impact in energy use equal to nearly 10 billion gasoline gallon equivalents. This infographic reflects some pretty substantial coalition impacts, such as 1 million alternative fuel vehicles on the road. GSCCC contributes to this impact. Each year, we collect data from our stakeholders for an annual report. Now, in 2019, New Hampshire stakeholders' efforts reduced 1.3 million gasoline gallon equivalents and 8,200 tons of greenhouse gas emissions. So not just a drop in the barrel. We promote alternative fuel successes and solutions through education and outreach, such as stakeholder meetings and events like our coalition's biennial Green Your Fleet workshop at the New Hampshire Motor Speedway, which you'll see in the upper right-hand photo, as well as the photo to the left of that, which shows last September's Bi-State Electric Vehicle Connector event, which was held at Hypertherm in Lebanon, New Hampshire. GSECC partners are putting the rubber to the road using propane school buses, as shown in the bottom right photo, compressed natural gas and hybrid electric transit buses, which are seen in that top left photo, or using biodiesel, which is a drop-in fuel, in their diesel dump trucks and pickup trucks. DOE offers resources that can help you do the same. Our go-to website is the Alternative Fuels Data Center, where you can find details about each fuel, including basic information, publications and case studies, laws and incentives, fuel pricing on a local, regional, and national level, and tools. For example, do you want to know what vehicle manufacturers offer, for example, electric street sweepers? Check out the vehicle search tool. We also have access to technical and problem-solving assistance and expertise. So not just within our own coalition, where there's a wealth of just knowledge and New Hampshire-based experience, but DOE also offers the Technical Response Service. This is a rapid response service for alternative fuel questions, and Tiger teams for technical problem solving related to actual vehicle deployments and fuel station infrastructure development. Now let's talk about electric vehicles. Why the focus on EVs? The simple truth is that electric vehicle technology is more efficient for moving cars around, and it's getting better every day. According to fueleconomy.gov, EVs convert over 77% of the electrical energy that they get from the grid to powering at the wheels. Conventional gasoline vehicles only convert about 12 to 30% of the energy stored in gasoline to turning those wheels. Now, there are two types of electric vehicles that use an external power source to charge an onboard battery: battery electric vehicles, or BEVs, and plug-in hybrid electric vehicles, or PHEVs. Now, both BEVs and PHEVs, which we collectively refer to as plug-in electric vehicles, or PEVs, use electricity to charge or fuel their batteries. So I've mentioned the two types of electric vehicles, but I kind of want to highlight their differences. Battery electric vehicles, or BEVs, are pure electric, powered by one or more electric motors. They can only go as far as their battery charge will allow them, which is why charging stations are so important. We've gone from having only a few electric vehicle models to a few dozen, with ranges from about 80 miles to 370. Plug-in hybrid electric vehicles, or PHEVs, are much like regular hybrid vehicles in that they have both an electric motor and a gas engine. But unlike regular hybrid vehicles, they can be plugged in to charge and can run 10 to 50 miles just on electric. When the battery charge runs out, the gas engine kicks in, keeping this vehicle running seamlessly. DES actually has 3 Toyota Prius Primes, and the last time I looked, they were getting over 70 miles per gallon, so pretty good. So let's amp it up and talk about positioning your community as an EV hotspot. Vehicle electrification is transforming transportation. Today, electric vehicles are in our fleets and on our roads. It's no longer the future. Electric vehicles offer benefits both to the environment and to the consumer because they have no tailpipe emissions when running on electricity. And even when you include power plant emissions, EVs reduce pollutants such as nitrogen oxides, or NOx. Over half of the pollutants that cause summertime smog and poor air quality days is NOx emissions from cars and trucks. Additionally, EVs emit fewer greenhouse gases, or GHGs, than gasoline-powered vehicles. And the GHG reduction of the electric vehicles will become even greater as a higher portion of electricity is produced by renewable sources. New Hampshire has a relatively clean electric mix, as you can see from this graph, thanks to our participation in the Regional Greenhouse Gas Initiative. This is why transportation electrification is a key strategy for achieving air quality and climate goals, and for integrating renewable energy into the transportation sector. Now, in addition to the environmental benefits, EVs are fun to drive, and EV capability and technology is rapidly progressing. People are excited about it. On average, thanks to fuel and maintenance savings, it costs about half as much to drive an EV compared to a similar vehicle that runs on gasoline. EVs have fewer moving parts compared to conventional vehicles. That means no oil changes, no spark plugs, no fuel components or emissions equipment. And according to a recent consumer report, EV and plug-in drivers can expect to save an average of $4,600 in repair and maintenance costs over the life of the vehicle. The U.S. Department of Energy's e-gallon tool at the bottom of the screen here shows that it costs $1.67 per gasoline gallon equivalent to fuel an EV in New Hampshire versus $2.12 per gallon to fuel with gasoline. What's more, the cost of EV batteries has decreased from over $1,100 per kilowatt hour in 2010 to just $156 per kilowatt hour in 2019. So as this price of this battery continues to fall, so will the cost of EVs. Electric vehicles are a fast-growing market. There are over 1.6 million EVs on the road in the U.S. today, and this number will continue to rise as more charging infrastructure is deployed, the cost of EVs decreases, the range of the vehicles increases, and consumers become increasingly aware of the benefits of driving electric. Some forecasts indicate that 20% of new cars sold will be electric by 2030, resulting in over 18 million EVs on the road in that year, projecting a need for over 9 million charging stations to support them. So we've got a ways to go. In New Hampshire, annual EV registration totals increased 28% from 2018 to 2019, most notably in Hillsborough and Rockingham. With many new models and a variety of body types coming out, along with these longer ranges and falling purchase prices, the rate of EV adoption in New Hampshire is expected to increase. Consumer acceptance will also continue to grow as new and diverse models are introduced. Currently, there are over 40 different models of electric vehicles available for sale in the U.S., including sports cars, sedans, SUVs, and minivans. Most major vehicle manufacturers have invested significantly in electrification and have announced that exciting new products are on the way, including more EVs with four-wheel drive, longer ranges, and electric pickup trucks. The market is growing, and as we look ahead, fuel and technology diversification is going to be integral to meeting our goals. Companies like Automakers, Motive Power Systems, and XL Fleet, which is headquartered in Mass, work with automakers like Ford Motor Company to integrate plug-in hybrid upfits and zero-emissions drivetrains and propulsion systems in these familiar and favorite commercial fleet vehicles like step vans, work trucks, etc. Hino, a Toyota subsidiary offering diesel-electric hybrid trucks, recently introduced a lineup of zero-emissions Class 4 to Class 8, so complete transition to full zero-emissions battery electric. And I believe we're going to see a lot more of this with California's recent mandate requiring all new medium and heavy-duty vehicles to be zero-emission vehicles by 2045. Electric is a great option in other applications like refuse trucks, forklifts, street sweepers, commercial lawn equipment, and on the larger end, transit and school buses and long-haul trucks. Electric bus manufacturers like Lion Electric, New Flyer, and BAE Systems, which has a presence in New Hampshire, are working with communities to deploy electric buses. In this photo, on the right, Nashua Transit held a ribbon cutting just last year for 2 new hybrid electric transit buses equipped with BAE Systems hybrid drive propulsion system. That's a mouthful. Electric vehicles need to be charged with electricity to fuel their batteries. Now, while studies show that 80% of charging happens at home, public charging plays a vital role in driving EV adoption. Charging stations, also referred to as electric vehicle supply equipment, or EVSE, connects the EV to the electric grid, and currently there are 3 different levels. Level 1, HAC charging, that's alternating current, consists of plugging the cord that comes with the car into a standard 120-volt AC wall outlet. It's your standard 3-prong household plug, and it's just like plugging in your toaster. This is best suited for home and workplace charging and provides 2 to 5 miles of range per hour of charging. This depends on the size of the vehicle battery. Now, since most, if not all, EVs come with level 1 charging cords, no additional charging equipment is necessary. Level 2 AC charging requires a 240-volt outlet, the same kind that's used by a dryer or an electric oven. This is mostly used in home, workplace, fleet, and public facilities and provides approximately 10 to 25 miles of range per hour of charging. And DC fast charging, or direct current fast charging, this requires a 3-phase 480-volt AC electric circuit and delivers a significantly faster charge. Now, most existing DC fast charging stations are 50 kilowatts, delivering 60 to 80 miles of range in 20 minutes. And these are primarily used to charge battery electric vehicles. However, there are now much faster DC fast charging stations, including ones that deliver up to 350 kilowatts, a wattage which is capable of delivering 200 miles of range in 10 minutes, kind of like that gas station feel. And these are mainly located in high traffic transportation corridors or public fueling stations. Now, for all levels of charging, it's important to note that no electricity flows from the charger until it's securely plugged into the vehicle, and that the EVSE then communicates with the vehicle to deliver a safe flow of electricity. Now, unlike level 1 and level 2 charging, there are different types of connector plugs for DC fast charging. There are currently 3 different DC fast charging plugs that are associated with different automobile manufacturers. Tesla uses its own proprietary plug that can be used by Tesla vehicles. European and American car manufacturers like BMW and General Motors typically use SAE combined charging system or CCS plug. And lastly, Asian car manufacturers like Nissan and Mitsubishi use the CHAdeMO plug. Now, Tesla stations, except for those, many of the new DC fast charging stations come equipped with those CCS and CHAdeMO plugs. Once again, important note, no matter which connector is used, it's important to note that DC fast charging is a safe technology that is built to code and follows rigorous safety standards. Now, DC fast charging stations are an essential component of the EV charging station ecosystem. Now, while it's generally understood that DC fast charging is needed to facilitate long distance travel, there are many DC fast charging applications for local EV drivers as well. DC fast charging stations provide a viable option for charging for people without the ability to charge at home, such as those living in apartment buildings. And they're also used by EV drivers to top off. As you can see, New Hampshire communities have permitted a few DC fast charging stations already. This map shows a few. But look at all of the communities that still need charging. We need to support this growing industry. In fact, the U.S. Department of Transportation, or DOT, has designated national EV charging and other alternative fueling corridors in strategic locations along major roadways. This is highways to improve the mobility of alternative fuel vehicles. To designate these corridors, DOT solicits nominations from states, and we participate here in New Hampshire in this program. New Hampshire's principal highways were evaluated against federally set criteria and designated as either corridor ready, which is basically meeting all this criteria and ready for signage, or corridor pending, meaning that it still needs some infrastructure on that corridor and it's not quite ready for signage. So for example, an electric vehicle or EV ready corridor is a highway or section of a highway that has DC fast charging every 50 miles and no further than 5 miles from the highway. The picture on this slide reflects New Hampshire's EV corridors. We have some that are EV ready, for example, a portion of the F. Everett Turnpike, which is denoted by the solid green lines, and some that are pending, for example, I-89 from Lebanon to Concord, which is the dotted orange lines. Additionally, we work with the New Hampshire Department of Transportation to finalize the corridor signage plans. The signs have been manufactured and installation has begun with EV signage on I-93 and I-95. This is a great way to promote the existence of charging to all drivers driving on our highways and major roads. So it's important that we strive to move our pending corridors to ready to support EV travel and further adoption and awareness. So if you're working on any EV charging projects in your community, these designations should serve as a guide for identifying and prioritizing sites that support these corridors. And as you might already know, New Hampshire is receiving approximately $31 million from the Volkswagen settlement, and Governor Sununu has committed the full 15%, or approximately $4.6 million, which is the maximum allowed under the settlement, to be used for EV charging stations. And DES is working with the lead agency, which is the New Hampshire Office of Strategic Initiatives. And last November, a DC fast charging RFP for approximately $2 million was released, seeking a network of EVSE on 6 of our FHWA designated corridors. Unfortunately, none of the proposals submitted met the minimum requirements of the RFP. Now, feedback on the appropriate design of a DC fast charging RFP was solicited through a request for information in a public listening session, and this RFP is being modified for re-release, further necessitating a timely need for permit streamlining. So if your community is near a principal travel route on this map, the odds are that you're going to be permitting DC fast charging at some point in the future. Per the DOE's AFDC station locator, that's that alternative fuel data center site I mentioned earlier, which is a tool supported by Clean Cities Coordinator. In New Hampshire, there are 94 publicly accessible universal level 2 charging stations with 157 outlets. There's 112 if you count Tesla, which, like I said, is only able to charge Tesla vehicles. States all around us have adopted California's zero-emission vehicle mandate, which is challenging automakers to work harder to bring competitive EVs to the market. In fact, Massachusetts projects to have 300,000 EVs on their roads by 2025. To prepare for this, they are building up their infrastructure, as noted in this slide of the surrounding states in Canada. Now, New Hampshire's existing infrastructure is not sufficient to meet the need, both for EV drivers traveling in and around New Hampshire and for those visiting us from out of state. We're working at the state level to fill the gaps, but the fact that there are gaps presents both a challenge and an opportunity for municipalities. You have the ability to simplify planning by implementing policies and processes that facilitate EV readiness. With the anticipated growth of EVs, the integration of EVSE should be incorporated in municipal planning and preparation. Public Level 2 EVSE offers many possibilities for municipalities. The cost of Level 2 equipment and installation can range from $1,000 to $20,000, depending on the location and whether or not there are existing circuits. When compared to DC fast charging costs, which can range from $15,000 to around $100,000, Level 2 charging makes the most fiscal sense for budget planning. Now, I'm sure you've wondered about those substantial swings in cost, and there's an explanation. The cost to install EVSE is contingent on what stands in the way. That's why it's so important to incorporate EVSE in new construction. To maximize the cost benefit, you need to plan ahead. Here are some strategies to consider. Lead by example. When evaluating your light-duty fleets, encourage EV procurement. With low to no maintenance and fuel costs due to those simpler and cleaner drivetrains, the cost of EV ownership can be much less than gasoline vehicles. And check out the state vehicle contract. Municipalities can purchase alternative fuel vehicles such as EVs and other fuel-efficient vehicles from that contract. Now, new contracts are usually published in the late fall, early winter, so about this time frame. So stay tuned and certainly email me if you're interested in seeing that contract. Install charging stations in your municipal parking lots and town facilities. This also offers a solution to your condo and rental communities and gives you access to charging data for future planning. Encourage schools to offer staff and student charging and to be aware of electric school bus pilots and funding opportunities, such as EPA's Diesel Emissions Reduction Act and school bus rebate programs. In fact, there's an open round of DERA funding being administered by DES to the New Hampshire Clean Diesel Grant Program, so please reach out to me if you're interested in more information on that. And consider electrification options for medium and heavy-duty transit fleets. The challenges of range and cost in this sector are being met by improvements in battery capacity and charging technology, along with manufacturer competition and decreasing battery costs. Become an EV hotspot. Identify strategically placed destinations for charging stations like popular restaurants, hotels, and shops to attract tourism and draw in business to your main streets. Now, charging an EV is a different experience than fueling a car at a gas station. Rather than waiting until the fuel gauge is near empty, EV drivers often take advantage of opportunities to top off. So while it takes longer to charge your car with electricity, it can be accomplished while you're doing something else. As you know, per the fire marshal, you cannot leave gas pumps unattended when fuel is being dispensed. When charging an EV, you simply plug in and go about your business. Public charging can provide a boost to local businesses because EV drivers often seek out stations they can use while enjoying a cup of coffee, dining, or shopping nearby. Now, in this next segment about planning and permitting, we'll dive further into this a bit more, but I want to call out the overarching considerations. Since local municipal governments and code enforcement officials are the authorities over planning and permitting EV charging stations. You could adopt EV-friendly zoning, parking ordinances, and building codes to encourage charging stations or the electrical infrastructure in new construction and parking lots. As I mentioned before, it's less expensive to install that wiring and conduit up front than it is after the fact. Encourage builders to consider EVSE when pulling permits for residential, commercial, and multi-unit dwellings. Adopt EV-friendly permitting and inspection processes to make it simple and easy for residential and commercial charging station installations. Suggest to station developers when they're pulling these permits to consider EVSE. Now, choosing a site for DC fast charging is resource intensive. When selecting a site, station developers consider many factors, such as local traffic patterns, EV adoption surrounding areas, proximity to major roadways, nearby services, safety, and appropriate lighting. Station developers also need to work with electric utilities to ensure adequate electrical infrastructure to accommodate DC fast charging. Available grid connections and electrical capacity may limit charger placement at a site. Sometimes easements from utilities and others are needed, which can add additional time and cost to securing a site and place restrictions on where the charger can be located. Lastly, the station developer and site host enter into a contract which often restricts or dictates the specific on-site location of the chargers. It's important to keep in mind that station developers must complete this resource-intensive process for siting DC fast charging stations before even submitting a permit application. Therefore, the clearer the permitting requirements are up front, the better equipped the applicant is to submit what you're looking for the first time around. There are several characteristics that differentiate gas stations from DC fast charging. The most obvious difference is that one involves gas, a toxic substance that can cause environmental harm when spilled or leaked and emits fumes that are hazardous to breathe, while the other uses electricity. Now, when gas stations that are open to the public are developed, they typically include a convenience store, which requires HVAC and plumbing equipment, and gas pumps, which require storage tanks and fire suppression systems. In addition, gas stations and their associated stores are normally standalone enterprises. On the other hand, as of now, DC fast charging stations are usually added to existing developments as an accessory use and can be installed in a variety of locations, including convenience stores, rest stops, malls, etc. Also, DC fast charging stations do not require storage tanks to store fuel. Now, while there are other differences that could be mentioned, the point is that gas stations should not be used as a blueprint for how to permit DC fast charging. There are billions of dollars of planned investment in EV charging equipment from electric utilities, states, and private EVSE companies. Therefore, municipalities will likely see more applications for EV charging stations in the coming months and years. Now, although municipalities may have experience permitting residential and commercial level 2 charging, New Hampshire doesn't have a state standard. We don't regulate from the state level. This is a town-by-town decision, meaning that each town has their own electrical permit and process. And this can be challenging for EV charging station installers and electricians to navigate. For example, some towns allow an application to be submitted with the master electrician's license number entered on the form. Some require a copy of the actual license, and others require the master electrician to apply in person with their license and driver's license to prove their identity. Note that requiring the master electrician to be there is an additional expense to the site host. However, with a structured and well-defined permitting process, these types of issues can easily be overcome. To the extent that communities can adopt similar permitting requirements, especially for straightforward level 2 charging, the easier it will be for station developers to navigate the process, and the more likely the investment will be made in your community. I'm going to launch another poll here and would love to get everyone's feedback on whether or not you have directly permitted or inspected EV charging stations and installations in your community. I'll give everybody a few seconds here to respond. All right, we're going to go ahead and close the poll. And it looks like we've got 14% that have, fabulous, 48% that haven't. So you're hopefully going to glean a lot from this presentation. And then 38% that are not in a position to be a permitting or planning official or inspector. Thank you. All right. So according to EVSE providers, the permitting process for EV charging stations is sometimes lengthy and fraught with delays due to unfamiliarity with the technology, protracted zoning reviews, and undefined requirements for permitting. As a result, the permitting process can be resource intensive for both applicants and municipalities. In some extreme instances, station developers have withdrawn permitting applications and found new charging station sites in neighboring towns, shifting that potential economic opportunity to other locations. Now, based on conversations with EVSE providers and by reviewing best practices and recommendations in leading municipalities, there are some clear steps that you can take to encourage EV charging station deployment and make the permitting process more efficient for everyone involved, from zoning boards to permitting officials to station developers to inspectors. You could standardize the permit review and inspection process for EV charging stations. EVSE providers report that when required, zoning reviews are usually the lengthiest part of the approval process and are not always necessary. Often zoning reviews are unnecessary because EV charging stations are an accessory use to the principal use of the site. That is, EV charging stations are usually added to existing parking areas for already developed sites. Now, in general, DC fast charging stations have a very limited impact on the locations where they're situated. They have little effect on area traffic, they don't consume unnecessary space, and have a short window of operation per vehicle. Some municipalities find that amending their zoning ordinances to clarify that EV charging is an accessory use that does not require further zoning board approval, and to clearly identify any exceptions can save time and resources for both zoning boards and applicants. Now, the Seabrook Town Planner advised that they classify EVSE, both level 2 and DC fast charging, as an accessory use, which eliminates extra reviews by the planning board. The City of Dover's site review regulations definition of EVSE explicitly states that it is permitted outright as an accessory use to any principal use. Municipalities can further streamline the review process by providing concurrent reviews for building, electric, and any other reviews necessary for the approval of a permit. It's also important to standardize the building, electrical, permit review, and inspection process, and to make the grounds for rejecting a permit application very clear up front. In addition, developing concise step-by-step checklists for inspections sets clear expectations about what will be inspected, which documents must be brought to the inspection, and who should be present. During the inspection process, inspectors should ensure that the project is consistent with the issued permits and avoid any additional requirements at that point. Some municipalities find that they can consolidate the number of required inspections for EV charging stations by conducting multiple inspections simultaneously. James, what are your thoughts here?
I'd love to see the checklists on the town website, Jessica. It would be enormously helpful up front for property owners to understand key considerations for safety and accessibility, for example. As an electrical contractor that specializes in this area, we know what to look for, but for your general electrician, they may not consider them. For example, the lowest cost place to install a station would be on a wall, but this often results in a cable draped across the sidewalk to the vehicle, and that may be blocking emergency exits, for example. And at a minimum, cables left lying on the ground. For this reason, we highly recommend using cable retractors that automatically pick the cable up from the ground. Also, charging stations are typically protected by large bollards, and if poorly sited, these can block wheelchair access to the station. With some upfront guidelines, projects can get off to a good start.
Excellent, thank you. Also, try to make the process for permitting EV charging stations clear and transparent. As a first step, clearly identify required application materials, where to find the permit application, permitting steps and associated timelines, any fees involved, and points of contact. Fact sheets are a convenient way to convey this information. Some municipalities even have a permit application specifically for EV charging that addresses both level 2 and DC fast charging. Prominently featuring these permits and fact sheets online makes it easy for station developers to locate this information and will reduce the time that staff spends responding to questions and dealing with incomplete applications. Consider offering options to submit permit applications electronically. Particularly now as we're dealing with the impacts of COVID, providing permit application forms online, ideally in a fillable PDF application that accepts electronic signatures, and allowing those applications to be submitted online or via email makes it easier for station developers to submit applications and much safer for permitting staff to receive and process them. Some online permitting platforms can also assist with internal reviews and communicate externally about the status of a review. Online permitting, or providing the option to obtain applications online and submit them via email when online permitting is not available, allows applicants to avoid unnecessary trips and associated greenhouse gas emissions to the permitting office and cuts down on lines at the permit counter. You might amend local ordinances to count parking spaces for EV charging towards minimum parking requirements. In some locations, minimum parking requirements are a barrier to siting charging stations because EV charging spaces are not counted as parking spaces. This can make it more difficult for station developers to find a site host. Municipalities can address this issue by updating local ordinances to clarify that spaces for EV charging count towards meeting the minimum parking space requirements. Some municipalities are incentivizing the deployment of charging stations, for example, adopting ordinances that count charging station spaces as more than one parking space for zoning purposes. Per the City of Dover site review regulations, the paved area application fee is cut in half if at least 2% of the parking spaces are for EV charging stations. And they've made an exception to their maximum parking calculation when EV charging stations are included. The town of Seabrook is believed to be the only town in New Hampshire that did away completely with minimum parking requirements, removing it from the zoning ordinance and the site plan review regulations altogether. James, what are your thoughts here on this slide?
I think it would be great, as charging stations often take more space than regular parking spaces due to the space requirement of the station itself, and especially if enough room is left to make them ADA compliant. This would incentivize installers, for example, to offer an extra 36 inches of a striped area for wheelchair access without penalizing the host for that extra space requirement.
Right. Consider developing expertise and sharing knowledge with station developers and other municipalities. Now, COVID-19 restrictions notwithstanding, it would be a great idea to offer pre-permit application meetings or reviews during the siting phase for EV charging stations, especially for complex projects. This would allow the permitting staff and station developers to learn from one another and provides an opportunity for staff to become familiar with the proposed project and identify any potential issues for station developers to consider. In addition, larger municipalities may benefit from developing in-house expertise or designating an EVSE expert who's the point person on EVSE permit applications. Finally, it can be useful for municipal staff to coordinate with neighboring municipalities to share best practices. Exchanging ideas, sharing resources, and creating some consistency across our region will ultimately improve the process for both municipalities and station developers. James, thoughts on this slide?
Sure. I'd say, as well as having a go-to EV contact at the town, it would be enormously helpful to know what days the inspector is available for office hours, what days and times they conduct inspections, for example. Avoiding telephone tag and scheduling work on inspection days significantly streamlines the process. I would also recommend connecting the building department with their town energy committee, for example, as the members are often active local advocates of clean energy and are in contact with potential site hosts that they can offer guidance to.
Right. And now, James, I'm going to turn it over to you for some more on the installer perspective.
Okay. So I just got some final considerations. I would like to add that really in an ideal world, all new building codes would actually mandate make-ready charging infrastructure. This can be as simple as adding conduit during parking lot construction and terminating it in a handhole for easy future access, or a more generous requirement might be to add conduit and stub outs by each dedicated EV parking spot. And that's that apparently is what's being enacted in other parts of the country more and more. So we can expect to see that kind of coming our way sooner or later. And then finally, in conclusion, I would say number one for us is clarity on each town's website. It helps electrical contractors streamline the process, know what to expect. So knowing who, where, and when to call for permitting and inspections help projects go smoothly, resulting in reduced labor and costs that will ultimately trickle down to property owners. Furthermore, it sends a signal that a town is encouraging EV driving and welcomes EV charging station development. Thanks so much. Appreciate your time.
Excellent. So curious to know from everybody out there, and please feel free to communicate with James or I, do you see any challenges with the considerations that we're proposing with these suggestions? And I'm curious to just check and see if we have any specific questions maybe that we can touch on quick, Colin, before we move on to the utility perspective.
Sure, there are a few. Just a couple of small ones. Will you provide the permitting best practices to share with community officials? I guess if there's kind of shareable materials that you can pass on to everyone that registered?
Definitely can do that.
Great. And then Another small one are adapters available to charge with a non-matching plug? I imagine it depends on the make and model and everything.
James, did you want to tackle that one?
Sure. Well, Teslas all come new with an adapter in the vehicle at no extra cost. So you don't have to worry about putting Tesla chargers in. You want to just put a universal level 2 charger in, and then rely on the Tesla customer to use their own adapter. At the fast charging level, you're really talking about Tesla drivers will be sticking to the supercharger network anyway. There are adapters on the market, but the simple answer is nobody really uses them because they're significantly slower than Tesla chargers. So yeah, I don't think you have any concern about adapters.
Time for a couple more, Jessica?
We'll take one more, sure.
Okay. Mark asked about the whole school buses issue. Since most of those are, the buses are actually owned by private companies and contracted with school districts, is there a way to work together for the school districts and the companies maybe to work together to share the cost of charging stations at schools? And maybe there's some examples of that. I haven't heard of that directly.
Yeah, I mean, maybe I could look into examples because I think that would be definitely helpful. And it's one thing that we are very much aware of. We did have an electric vehicle request for proposals through Volkswagen funding for school buses, for electric school buses last year. And unfortunately, we didn't receive any responses to it. I think a lot of it is as a result of the fact that a lot of the schools don't own their own buses. So it is a little bit more challenging, right? Because now you have to work with a different partner in coordinating whether or not they want to take on this new technology and about the cost. But it's something that definitely needs to be considered and talked through, and certainly reach out to me. I'd love to maybe brainstorm more on a conversation and moving that thought forward, because we would love to see that happen. All right, so thank you very much, Colin, for those questions, and thank you, everybody. Continue to, as I mentioned, please use the Q&A box to enter your questions. And thank you so much, James, for your assistance there. As a reminder, Granite State Clean Cities is here to help. You know, we're happy to facilitate conversations and connect you to resources and other people. So once again, as I mentioned, please reach out to me. And now I'm going to turn it over to Sean Tully for the utility perspective. And here's real quick, here's Granite State Clean Cities Coalition's information as Sean's getting ready to share his slides. Go ahead, Sean.
All right, I'll give that just a minute there so people can write down take a screenshot there of.
Yeah, and I'll be sharing everything as well, but thanks, Sean.
Great. All right, I think Jessica, you just need to unshare so I can.
Oh, yeah.
So, and as we're getting started, just a quick note about the bus situation. We have talked with some communities in our service territory, and what they're looking to do is, if they certainly have an interest in working with transportation companies, regional bus transportation companies, they're kind of aligning and partnering with their neighboring communities as they're getting close to an RFP period. So these neighboring communities, everybody that is served by that bus transportation company, of doing a collective RFP to start rolling out some EV infrastructure. And even, there's conversations around, is it better for, the charging infrastructure to be at the transportation company depot, or partially doing some of that charging infrastructure at municipally owned facilities, the school parking lots, things like that, for those electric buses. So those are some conversations that are going on. But I think, if the municipality does not own those buses themselves, they should look to have a combined RFP with neighboring communities and partner. That'll bring a lot of strength to the process. So thanks everybody for your time today on a Friday. Really appreciate it, and very, very glad to be here to talk about. We're about 2 years into a Make Ready program in our Massachusetts electric service territory, and just talking about some of the lessons learned and things that we have gleaned from our process in working with municipalities in eastern Massachusetts, on Cape Cod, Martha's Vineyard, and in western Massachusetts, and then talking with some of our municipal partners in both Connecticut and New Hampshire as well. So just talk about a quick overview about what our program is and some of the things that we're doing there. Talk about a typical EV scenario, something you might consider in a municipal parking lot, or somebody, a constituent in your town might talk about, and some of the lessons learned, zoning considerations. And then something that's been coming up a lot, especially with municipalities, is integration of EV charging with other technologies, battery storage, photovoltaic systems, and other distributed generation systems. And then some final thoughts. So presently, Eversource is rolling out a $45 million capital investment in our electric service territory in Massachusetts, where we will cover, it's a capital investment, and cover 100% of the infrastructure costs for a service dedicated to the EVs in a municipal or commercial customer's property. And this was really modeled after, our program was modeled after an offering with Southern California Edison, and that has since been picked up by DTE in Detroit, Duke Energy, another phase in SoCal Edison's service territory. And this Make Ready program and doing everything in future-proofing a site as much as you can while you're doing that initial pondering of how you're going to roll out EVs for your customers and for yourselves. It's really, there's some things you can do that will really make it easier going forward in the future, because right now some of these sites may be looking to do 1 or 2 dual port chargers that would have about a little over 7.5 kW per port. That's the charging technology today, but it is very quickly changing. As Jessica mentioned before, a lot of the DC fast especially is, a few years ago, 50 kilowatts was the max. And now, although there are very few cars that can accept a 350 kW plug, they are coming very quickly. And it's a significant system and power consideration to be able to handle that load. So, we will look to cover 50–90% of the project costs. We have a goal of 3,500 charging ports, both level 2 and DC fast, across our service territory in Massachusetts. And really a big piece for Eversource is the equity, and 10% of our capital deployment is for environmental justice communities. So those are certain census tracts. Tesla has a lot of money, and they're certainly rolling out their program and their superchargers, but we want as the utility to be able to have offerings that would equitably distribute these for all of our commercial customers. So we've extended our kind of consultation to just that service, but also designing and standardizing some behind the meter conduit sizing, cable sizing, and a control box enclosure that I'll talk about that we deploy on our customer sites. So as Jessica mentioned, there's different levels of charging, and we've really found that you want to look at different charging levels for different locations. Level 2 is about 6.6 kW up to 10 kW per port. That's great for public parking areas, maybe in Manchester or Concord, where there'd be where they would allow possibly overnight municipal parking, where somebody that doesn't have a level 2 charger at their home, be able to charge their EV car overnight. Certainly workplace, universities, and multi-unit dwellings, that makes sense. So that DC fast, 50 to 350 plus, that's really great, as Jessica mentioned, along those travel corridors, or also having a community charging hub in the center of a community, where it would be a highly dense area and there might be a lot of turnover, like you might find in Portsmouth or downtown Concord or something like that. So a typical scenario that we found a lot with our municipal partners is, looking to roll this out in municipal parking lots. So just wanted to talk through, how we approach this project and what we standardize here. So this is a town in eastern Massachusetts, where they wanted to start with one charging station in the small municipal lot in the downtown area. And fortunately, it was close to some overhead. So typically what we look to do here is have a new service, to come down off of one of our utility poles. You'll see a proposed control box enclosure that we have there, and that charging station that we would install, and it would be ready for the user to use. So this is something that, all of this installation is something that's sponsored under our program, and we're especially proud of the control box enclosure because we think it really addressed a lot of the concerns of some of the code officials and authorities having jurisdiction over safety around rolling out EV charging infrastructure in school parking lots and public areas. Sometimes especially if it's a commercial real estate space, or certain areas, the biggest system in that area might be 277 480, so a higher voltage than that's required for a level 2 charging station. So in that control box enclosure, we made sure we have a dry type transformer. It doesn't have any open venting or anything like that, tamper-proof hardware. So, if you do have a school parking lot or something like that, or a park, and there's kids climbing all over it, there's not going to be any threat of anybody being hurt there. Another consideration was around first responders. If there is a snow plow or a car accidentally does knock one of these over and you do have open conductors, there is a way to de-energize it and make it safe. So we developed this with one of our engineering consultants. This is an example of a 208 3-phase deployment, and we really believe we want to give the ability to expand. If you're tearing up a parking lot, as James mentioned before, you want to be able to put in the conduit and you want to be able to put in the infrastructure there to do it. Typically, if you're, maybe there's a building nearby and you can find an open panel, level 2 chargers, they'll look for a 40 amp 2-pole breaker. So you may be able to find space in an existing panel in a nearby building that has maybe space for 1 or 2 of those breakers. But if you wanted to expand that in the future, you're really going to have to upgrade that panel in the building, and possibly upgrade the service. This can trickle down to having to upgrade the switchgear, having to upgrade the service in that building. So for open parking lots, municipal parking lots, we really think it's best to establish a new service. We for a lot of our standard offering in Massachusetts, it's 10 parking spaces. Whether you are looking to install 2 ports, 1 dual port charging station or more, the minimum that we offer our equipment in, it's behind a NEMA 3R enclosure, is for 10 vehicles, because we'll have the load center there, the metering, the switching, all that equipment will be appropriately sized to be able to offer some expansion in the future. So one of the things that was very important to a lot of our code officials in Massachusetts as we were rolling out this enclosure was, they wanted to be able to have individual disconnects for every charging station. So if there was a problem with one of them, like I mentioned, it gets knocked over by a snowplow or something like that, you wouldn't have to take out the whole system or the whole parking lot if there was a problem. So we have all of our disconnects and everything within line of sight. It's in that parking lot or in that garage, and it's behind a locked cabinet with a padlock. That if a utility or first responder needs to come, would be able to get in there and make it safe. It's a UL listed piece of equipment. Sometimes, there can be, instead of having this enclosure, a lot of the early deployments that we've seen, especially if it's an open parking lot, was a unistrut rack with a meter socket hung on it, a panel hung on it, and we believe it's much safer to have everything locked behind a 3 NEMA enclosure that is UL listed and certified. So there is also, if a first responder does need to get into that piece of equipment, make it safe, there's a dead front enclosure, so you can have access to the load center, but you can't take the front off of that and have open conductors without de-energizing the whole enclosure. And as I mentioned, it's lockable, fully accessible to the property owner and the utility or a first responder, and has fully tamper-proof hardware. This is something that we want to keep everybody safe as we're rolling out these deployments. So a few site planning considerations, as Jessica mentioned, zoning. EV chargers are not filling stations. We've run into that quite a bit. Some other things that got caught up in some municipal review is some historical districts. We had some areas of some towns where there was some considerations around, a lot of these charging stations have LCD screens, in front of them for a paywall, to be able to, charge the customers, so they can pay for the electricity to plugging in there. And because of that screen, it was shot down in the permitting process because it was considered a historical district and an area where they wanted to, the town, it was very important to the town that they didn't have, any kind of LED marquee signs or anything like that to keep that historical feel. So that's something to have kind of clear, in your review process as it goes possibly through different departments in your municipality. We really wanted to have separate metering for all of these EV services, a separate from a building meter. One of the things that Eversource we think is important, we can continue to have conversations with our regulators around an electric vehicle rate. We do have the EV rate in other parts of our service territory, not presently in New Hampshire yet. I think that may be coming sometime soon, but having a separate meter and a separate service, as you're deploying these EVs, it would perhaps have a different rate structure that would be more beneficial to that load profile and when EV stations are charged. Some other code considerations to consider when you're rolling these out. James talked about, we talked a little bit about the parking spaces. I think having for new construction or a new parking lot, minimum make-ready requirements would be good. If a new construction project is going in, it's tough to dig up a parking lot after it's been set. It's a lot tougher to resize electrical equipment that the project bought. So, they may be looking at buying a big piece of switchgear. If it's a hospital or commercial real estate, having that capacity built into that switchgear day one will help things moving forward. Another thing that James mentioned was the conduit and having handholds. We're a big believer in that. A lot of times, in our deployments, would encourage municipalities in the permitting process to have a drawing review and have some recommendations to oversize conduits, put in spare conduits, because right now, stations are level 2 basis, and they may use per plug like a number 4, number 2 wire, and some of the other service laterals and things like that may be a 4/0 or 1/0 cable. If charging stations, a lot of these manufacturers are coming out with new models and new capacities, and as the battery size increases, the level of charging needed to charge them in time, would increase as well. So having that conduit oversized, so in the future, you didn't have to tear up the parking lot again. You could just, have the appropriate size conduit in there and be able to reconductor that conduit and not have to do any more site work. Is something that we think is very important and something to think about and encourage with your permitting review process. So there might be some recommendations that you might have to be able to future-proof the site as much as you can. So another consideration, something that we've been talking about, is the integration of other technologies. So, certainly we have some customers that are looking at, doing photovoltaics. They're looking at doing some solar canopies, EV charging on the site, and also potentially, using some manner of battery storage. Make sure you talk with the utility, your customers, and the municipalities. Talk with the utility early, because it will, doing some smart planning and figuring out what the overall master plan is for a site can really help minimize the system upgrades that the utility will need to bring, and the number of services that the building will need, that the utility will need to bring onto the customer premise. To give you an example, we had a new school, and so there was a service that was brought onto the new school, secondary service, and then a large solar canopy that was proposed by a solar developer. That was a second primary service feeder that was brought onto the premise, and then they wanted to participate in our Make Ready program. So we ended up bringing, between the building service, the PV, and everything, proposing to put on 3 feeders onto that property. And the wire inspector started to say, there's got to be a better way to do this. There's no need to have to bring on that many services onto one property. You guys have to figure it out. So ultimately, we ended up having to really alter one of those other services and do a lot of rework to make the project happen. So that could have been avoided if we talked early and seen what the master plan was. If there's a lot of times, these things are starting to go hand in hand now. The people put in the solar canopies, and then they're looking to add EV as well. So please talk to your utility partners early and really encourage. If there's a permit that's coming in for solar canopy or for EV, talk with the utility and see, what is the biggest, is there going to be other things you're going to be doing there, and make sure that there's a solid plan going forward, because it might make sense, if you're putting in charging station, for level 2 charging station, maybe a broad deployment, we might look to do a 208 transformer. But then if you're looking to do DC fast, instead of doing a 208 initially, it might make more sense to do 277, 480. Then that same transformer could be used for a solar canopy or some other technology that would be coming onto the site potentially. So that's all I had. Certainly, open to any questions or discussion. I think I saw some of the Q&A popping up there, so I wanted to leave some time for some questions as well.
Great. Thank you so much, Sean. Yep. Now we'd be happy to take any questions from the audience. Colin, if you've got questions for us.
Sure. Since I'll try to jump around and get to all of them here, but let's start with the utility-related ones that popped up, since that's what we're on here.
Great.
So I guess for you, Sean, will Eversource consider waiving the additional charge for over 50 kilowatt stations, I assume, for EV charging?
I'm not sure I quite understand the question. One thing that I hope this answers it. One thing, we have some standards for reliability. Certainly if you're looking at a large DC fast deployment, you know, we would look to not only put in, you know, we would need to have a pad transformer for the proper transformation, but we'd also put in switching to be able to have that reliability, you know, to be able to service that load. So that is, if it's over, you know, I think getting close to 350 kVA, I think in New Hampshire, we'd look to have some switching as well, you know, just for reliability for the neighboring, you know, customers that are served out of that area. But I'm not sure if that answers the question.
It sounds like there's an additional charge for greater than 50 kilowatts. So maybe if you use, there's an extra demand charge for over 50 kilowatts.
Oh, I see. Okay. Yeah. So, you know, presently, you know, we work through the rate structures that are approved by our regulators. You know, I do know that you know, these are reviewed from time to time, and that's one of the reasons that we really want to, you know, make sure we have these DC fast stations and level 2 stations, you know, set up on their own service and their own meter, so they can be more easily, you know, moved over to a more demand-friendly rate in the future.
I might just add, Sean, that I think the New Hampshire PUC has some public comments, and this is in process right now to offer some alternate way of to minimize the demand charge for DC fast charging.
Sure. Yeah. There is some conversations around using more of a volumetric rate than a traditional demand, because the load profiling, you know, is different for a DC fast charger than a traditional large commercial customer. So that's something that you know, there are conversations about with our regulatory folks.
All right, great. I want to make sure we get to as many of these as we can here. So you have the perspective from Eversource, Sean, but you know, there was a question here if Unitil is responding to EV charging in similar ways, or if they're doing something different, or is there kind of consistency among utilities for their, you know, ratepayers and so forth?
You know, certainly in, I can't really speak for New Hampshire specifically, but I know for, you know, in Massachusetts, you know, Eversource has our program. New Hampshire has a program in their, or I'm sorry, National Grid, excuse me. National Grid has a program for their mass electric service territory, and we meet with them regularly to talk about, you know, lessons learned and how things are going with our various programs. And, you know, similar to our energy efficiency programs, you know, as we do more phases, we want to take those lessons learned from our sister utilities and you know, roll them into consistent offering across the state.
And I'll add to that, you know, whoever asked that question, if Unitil is your utility, you know, feel free to contact the representative on your utility bill and let them know that you're interested in, you know, in getting, you know, some programs or rates around electric vehicles. Sometimes it just takes, you know, people asking for utilities to go, hey, there's a lot of interest here, you know, there's something for us to look into, and maybe even ask them, you know, where they're at in that process, because they may be working on that on their own and have some things to offer. So don't hesitate. I was advised by utilities that the name on your, the representative on your bill is the first point of contact. So give them a call and, you know, express your interest in that and find out what they're working on.
In my experience, Unitil, they don't have any programs financially, but they are very receptive to sending a representative out to meet with you and discuss some of the best practices and help you with engineering the product, the project, basically.
Great.
So is there, there was a question that popped up, if there's someone specific that someone can talk to at Eversource to discuss location for stations in their city. I don't know if you're able to post contact information, Sean, or if that can be part of our follow-up packet. Jessica?
Actually, yes. So like I said, what I've heard directly from the utilities is that look at your electric bill that you get every month, and there is a representative name on there, and that is the first point of contact. They will get you connected to the right people. So you do have that. You have access to that information.
Okay, I'm going to try to go back up to the top here from questions from a while ago. Can you indicate the rate of increase in demand for EV charging stations per 100,000 residents? So I guess like the rate of demand. I'm not sure I totally understand that question.
I don't have those numbers, but that's an interesting question, something I can look into. I don't know if Sean or James have any insights on that rate of demand per 100,000.
Yeah.
Well, I guess I could say that the one thing that we're tracking is the new registrations of when it's registered, obviously they know what kind of car it is, when it gets registered with the state. So we do get some information on, for this calendar year, there was this percentage of increase of new registrations of plug-in hybrids or battery electric vehicles. So that has been increasing by double digits every year over year for a while now. So, as a function of that, the demand for charging infrastructure will follow.
Yeah, and one thing real quick, James. So we do receive data from the DMV, and that's where, and earlier on in the presentation when I mentioned that from 2018 to 19, there was a 25% increase in EV registrations. So we do have some data like that. I just don't have it like drilled down to deeper numbers per 100,000, for example. So James, did you want to add something?
I was just thinking, I don't know whether this is relevant to the person's, to the answer, but I would look at maybe people coming from out of your area that would be interested in using the charging. So you might actually be needing to look at what's the demand in Massachusetts, for example, if you're in a municipality that is interested in supporting tourism in your area. You need to be looking at or Quebec, for example, where the numbers are going off the charts right now. I think the adoption rate for EVs in Quebec is higher than anywhere else in North America, and it's right on our border. And so you could be looking at how many EVs you're selling in your county, and it might be 1 per 100,000, but only 100 miles north of you, where you're trying to attract Quebecois down with their EVs, they might be at, I don't know, 1,000 per 100,000.
True.
So a couple more here to make sure, I'm not sure how much time we had here for questions and answers, Jessica, but
Yep.
I think all the questions will be recorded and kind of cataloged along with the recording here. So maybe there's an opportunity to follow up if there are any we miss. Question here kind of on the kind of grid side, as we're starting to see vehicle to grid charging technology enter the marketplace, does this complicate permitting for residential and commercial charging? So since this means bidirectional charging to and from the building's grid, and are there any foreseeable complications with the standard permitting process that we're talking about here?
I don't know if Sean or James have any experience with this or any thoughts on this.
I think Barry knows more about it than we do. Maybe we should get Barry on the line.
We'll need to phone a friend. I suspect doesn't this get into net metering issues that are going to differ from state to state? And I know New Hampshire has changed from year to year. So yeah, that's a pretty in-depth question there.
All this technology is coming down the pike at us. So in a couple of years' time, we'll definitely be addressing this, Jessica, I'm sure.
Yeah.
Permitting 102.
Yeah.
I have a quick follow up on that actually, which I'd love to just pose this to Sean. So we have situations where the host has a limited capacity in their panel, for example. They're not in Massachusetts, so they're not eligible, obviously, for your system. So what we'll do is we'll do some load sharing by using the software to do this. So we put obviously 40 amp breakers in for each circuit. So the inspector is looking at the size of all these circuits, and if you were to do a load calculation, it would blow the panel out of the water numbers wise. But obviously we have it so it's never going to exceed the load requirements. Is that something that you've run into issues with inspectors? And if not, I would just pose that as an alternative to New Hampshire municipalities when they're trying to reduce the cost of their installation, that they don't necessarily have to do massive infrastructure upgrades if they're just needing to add maybe 2 to 4 ports.
Yeah, I think that you want to. This is more of a code question, and I'm not an NEC expert. I know enough to be dangerous, but I think that authority having jurisdiction would look to have the circuit be service rated and rated for the piece of equipment that's being tied in. And not overload the panel, not, having to have those breakers not overloaded, because that's the piece of equipment, that's the technology, that's the charging station that's there now. And so, what's the protection if there is some kind of software failure or somebody goes in and reprograms it, then you're overloading the circuit and you're going to run into a problem. So I think there's definitely code consideration there. And I think you wouldn't want to put in breakers or have a circuit pulled off a panel that it could get changed on the software setting, and then run into a problem.
Yeah, thanks.
So a couple more here, Jessica. Sort of a note for follow-up. If you can share the number of EV and plug-in regulations. I'm not sure if there is sort of a compendium of state regulations to keep track of. I think that's what the question is here, from Drew. And this one's more on the RPC side, and I agree with this. This is from JB Mack. If anyone is aware of any more in-depth EV charging programs available, for example, if an RPC wanted to provide technical assistance programming to municipalities interested in streamlining their permitting processes. So maybe that'd be, I don't know, something for the 9 of us and to work with you, Jessica, in terms of a I'd be interested in learning more how I can help municipalities get their stuff off the ground.
Yeah, and I think it'd be great to get a conversation in place with, code officials and inspectors too, and kind of hear from them, what challenges are they facing, and kind of have a little back and forth dialogue to see, what is possible here in New Hampshire and what can we do to streamline, what kind of support can we provide to help move that, those best practices forward. I think that's a great idea, Colin and JB. Thank you.
One other one here. Can utilities develop a better EV charging rate for condominium associations that is not based on time of use? This would be kind of a bigger incentive.
Again, we're working the rates that are approved by our regulators in New Hampshire. Mm-hmm. I think a condo association, depending on if it's kind of a multifamily high rise, and there's kind of a house circuit and then tenant circuits. you know, I assume this would, if it's in a parking area beyond that commercial meter for any other house load. You know, this again speaks to the importance of having this EV infrastructure, you know, set up on a separately metered or separate sub meter at least. So it would be able to take advantage of you know, more EV friendly rates in the future.
All right, and would it be possible to, or are utility companies, would it be possible for utility companies to consider not requiring a meter for EV charging at condominium associations, as the metering can be the charging port, since the cost of a meter is a cost barrier? Did I say that well enough?
Yeah, well, I mean, if we wouldn't require a meter for EV charging, you know, per se. You know, we have a meter for our program in Massachusetts because it's a program and it's a capital deployment from the utility. So it's infrastructure that, you know, we would be rate basing. So, you know, certainly there's not the requirement from the utility perspective to have a meter for each port.
Okay, great. I think we're getting, there were some kind of ad hoc responses here in the chat pod or the Q&A. Any word from James or Sean, any word coming down the pipe from new incentives or new programs from the incoming Biden administration on EV charging?
Yeah. Yes, definitely. There are generous ones, I believe. It's worth having a read on his original manifesto. But at a minimum, right now we're looking at 30% investment tax credit for individuals or businesses. That's something that's been ongoing. I guess it depends on whether Congress re-ups that after this year. But I think there's going to be a big rollout for that. Maybe they'll package it with some infrastructure investment.
Yeah.
Road infrastructure.
Sounds like potentially good news on the horizon for
Definitely.
Folks looking to invest in this sort of stuff.
All right, Colin, I think we're good for Q&A. I've got a couple of closing polls I'd love to launch, and just let's get that up here. Hang on one moment. All right, so for this poll, we'd like to know how applicable was the information that was provided in this training today towards the permitting process for EV charging stations in your town or city? Give everybody a few seconds more here. All right, we're going to go ahead and close the poll. And I'll share the results. We had 68% somewhat applicable, so we've got some more work to do here. 26% very applicable. That's great to hear. We're glad we met the need. And for those of you that are interested, that answered somewhat applicable, would love to hear from you. What is it that you need? What more do you need from us to help that process? Or what kind of connections can we help make? One more poll I'm going to launch here. So how do you intend to use the information that was presented today? Give everybody a few more seconds here to get your vote in before I close the poll. All right. And share the results. So 78% plans to speak to those who have authority to streamline the EV charging station permitting process. Thank you so much. That's great to hear. 44% is going to continue to gather information in consideration of streamlining the process, and 17% will work on streamlining the process in their town or city. So that's fabulous. Thank you so much. As I mentioned, you know, we're also grateful for your time today. I just want to close by saying, you've heard the adage, it's better to be proactive than reactive. You have the power of decision-making and planning to charge ahead and meet the EV future on even ground, preferably with conduits running through it. Thank you so much for your time today. And to the presenters and to Stratford Regional Planning Commission, thank you for your guidance and assistance. We appreciate having you part of this conversation. We'll make sure that we follow up with some information and resources, and be sure to reach out to us with anything else that you need. Thank you so much.
Thanks.
Thank you.
Thank you, Jessica.
Thanks
Thank
all.
you, Shana.
Thanks, everybody.